So the problem says we have a 75 milliliter solution of hydrochloric acid, but we don't know the concentration. And that hydrochloric acid is going to be titrated with calcium hydroxide, which we know has a volume of 27.3 milliliters and 0.157 molar. We also know that the solutions are titrated to the equivalence point, meaning that all of the moles of calcium hydroxide are going to be added to react with all of the moles of hydrochloric acid. And with all this information, we can find the concentration of the hydrochloric acid. So now we're going to make the particle picture for both of the solutions. So with hydrochloric acid, we know that it's a strong acid, which means it's a strong electrolyte. So it completely separates into ions. So we're going to have one H plus ion and one Cl minus ion for every mole of hydrochloric acid. And the volume is given as 0.075 liters, and we don't know the concentration. And calcium hydroxide is an ionic compound, so it's also a strong electrolyte, and it completely separates into ions. So for every Ca2 plus ion, there's two OH minus ions. And we know 0.0273 liters is the volume, and we know the concentration to be 0.157 molar. So now looking at all the given information, we know that to find the concentration of hydrochloric acid, we're going to need the moles because we already have the volume. So to find the concentration, we need the moles. And to find the moles of the hydrochloric acid, we're able to use the moles of the calcium hydroxide because we know that all of the moles of calcium hydroxide were added to react with all of the moles of hydrochloric acid. So first we're going to find the moles of hydrochloric acid. So like I said, to do that, you're going to find the moles of calcium hydroxide, which by this equation is the volume times the concentration, which is here. And then we multiply that by the balanced equation, which can be found up here. There's 2 moles of hydrochloric acid and 1 mole of calcium hydroxide reacting. So we plug all that in to get 0.00875 moles of hydrochloric acid. And now that we know the moles, we're able to find the concentration by dividing that number by the volume to get 0.114 molar of hydrochloric acid. So the most common mistake would be to forget to use the stoichiometry in the balanced equation and to instead use M1V1 equals M2V2 to find the concentration of hydrochloric acid. And this wouldn't work in this particular problem because there are 2 moles of hydrochloric acid that react with 1 mole of calcium hydroxide. So we have to take this into consideration when using the moles of calcium hydroxide to find the moles of hydrochloric acid. We have to convert between the two, and as we can see, these two cancel out and leave you with hydrochloric acid.